This will be fun. Oh,
there you go. Minimize.
Okay. Get that out of the way. All right.
So it is being broadcast on Google Hangouts and recorded. And I'll go make sure it's working.
Okay, so I'm going to jump back and forth a lot. Highly demo. I have a lot of demo in here. Very few slides, a lot of demo. Spend most of our time in Code and Management Studio. My name is Brandon Preece. I am the manager of the database team at Sorensen Communications. I am on Twitter at SQL Border. I like to snowboard. That's where that comes from. And for those that are going to the summit, my plug, we're going to have a networking breakfast in Seattle at a awesome little cafe right close to the convention center. Thank you. So come and join us. Say hi to everyone. Have some breakfast.
It'll be super fun.
It'll be way fun. So it's on Meetup as well. So if you are going to pass and are on the Meetup page, does everyone know about the Meetup? Okay, so yeah, it's on Meetup. You can go and RSVP and then come and hang out with us for an hour or so. Come on in. All right, so to begin with, how many have heard of table partitioning in SQL Server? How many have used table partitioning?
In SQL Server?
In SQL Server. So when I first started thinking about doing table partitioning, it's a lot of manual labor. There's no like GUI or wizard in SQL Server like there is for so many things that says, hey, I want to partition this table, and it walks you through and you click next, 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 and you're done. It doesn't work that way. You've got to set it all up from the ground level. And so you look at all these words, and I know not every word in here is a partitioned word, but a lot of them are. And you look at this and you're like, man, that's a lot of stuff. I'm going to stay away from that. It looks hard. It's not very hard. It's pretty easy. And so the purpose of my presentation today is to kind of walk you through kind of from 99 level and then a glimpse into maybe the 201 level of table partitioning. So my disclaimer is, and people can own and hiss, but you have to have Enterprise Edition of SQL Server in order to partition tables. So if you don't have Enterprise Edition, go talk to your boss, I guess.
Or find a new job.
Or come work for Sorensen.
Those are your only options?
So to begin with, I'm pulling out a few little quotes from MSDN articles about table partitioning. And the first thing I want to say is you're already using partition tables, all of you, because every table in SQL Server is partitioned already, right out of the box. That's how it works. It's just a partition of one. And then what you're getting from partitioning is you're trying to horizontally divide your table into smaller sets. So one of the things that partitioning does really well is it gives you the ability to take that really large table that's hard to use and split it up into smaller subsets so it's easier to use. And there's a variety of different things that makes your life easier, and we'll touch on a lot of that. So why do I need this? And I'm curious on a couple of these, so I'll ask for some hands here in a second. So first of all, it's large table support. So that table that has 1 billion rows, that every query you run takes 30 seconds just because it has to find the data it needs. Partitioning is awesome for that. Data retention. Does anyone have a data retention policy at their company? You can't keep any data over this amount of time. So
you keep data past.
Yeah, so one of the things, that's what got me into table partitioning, was I had a requirement that was given to me by the attorneys that said, you can't keep any data over 5 years, get rid of it all. And I looked at my big, massive data warehouse and I said, yeah, that delete statement's gonna run for like 5 days. And it's gonna block your table, and then I'm gonna have to run it all the time, so you can't run any queries anymore either. It just doesn't work that way, right? So I had to find an answer, and it was table partitioning. The other thing is, I have a grumpy sand guy at Sorensen, and he told me one day that my big data warehouse was taking too much of his fancy tier 1 and tier 2 disk, and I needed to get that data that wasn't used anymore on the other tiers of disk on the SAN. And so again, table partitioning solved that for me. I can take my horizontally partitioned table and I can put it in different places on the SAN and everyone's happy. Performance tuning. So there are some ways you can get faster tuning queries out of server with table partitioning if you do it correctly. Otherwise, it won't fix anything. Well, I'll show you what that means here in a second. Column store indexes. In Microsoft SQL Server 2012, if you want to do column store indexes, if you put one on your table, you can't update it anymore. So, but it does support partition swapping or switching. And so I can get me a updatable table with column store index on it that makes my queries really fast. And I do that using table partitioning. And then finally, one of the nice things that you get, this is not the end of the list, but kind of my top few, backup and restores. I can back up, in SQL Server, you can back up a file group. And I can put a table partition on a file group, and I can put it on a whole bunch of different file groups. And so if I wanted to back up my database with a strategy of just backing up where the data is updated, I can make file groups, leave the ones that are old data maybe unbacked up, and so I can get a little bit faster backup restore with partitioning my data. So what is it? How does it work? The first thing is you have to have a table, of course. You can't partition a table without a table. The next thing is a key. You have to have a partition key, and that's generally your clustered index. So whatever you're clustering your table on with your clustered index is where you put your partition key. You need a partition function, partition scheme, and then you need a file group. Well, SQL Server comes with a file group right out of the box called primary, and you could just use primary. It will work just great. But if you want to get to that, I want to separate this table into multiple different places and put those on different disks and things like that, then you need multiple file groups which have multiple files, or a file in each. And then I can stripe that table across disks. And I'll show lots of examples of this right now. Okay, so I am starting with a very vanilla database called AdventureWorks, and I'm sure everyone's used before at some or another. But I have ran SQL Skills script that enlarges the AdventureWorks database, just so I can have some more data to show you how cool table partitioning is. So to begin with, what I want to do is just show you that this database is just AdventureWorks, nothing fancy. So I've got two files, a data and a log, an MDF and an LDF. I have one file group, just primary. Nothing fancy here yet. We're going to go through the process of making this database a little more fancy as we add things to it. So the first thing I want to do is we're going to add some file groups. Does that black on white look horrible back there? Or is it okay?
I would just increase the size.
Okay. Of course, my Management Studio freezes when I do stuff now.
It's because your SQL prompt.
You think it is? You can cancel that. Nope. We'll give it a second. I won't drag and drop next time. I've learned my lesson.
There are so many little things you have to learn about Management Studio to keep it from crashing. It's kind of sad.
All right, let's try
There's
this
some
again.
really cool stuff that you can do too.
There is.
I'm going to blame it on Google Hangouts.
That's
Just
not a
because
bad
it's
idea.
Google.
I won't disagree with how many issues I've had with Google
Some
Hangouts.
iPhones know.
No, you can blame Google Hangouts, trust me.
And we're back. Okay, so the first thing I'm going to do is I'm going to add 4 file groups. Just because 4 was a nice round number and I thought to add 4. Why not? You can add any number you want. Okay. Now, I really haven't done anything but add 4 file groups. In fact, SQL servers are going to do absolutely nothing with this right now because I haven't told it to do anything with it. It's just a database now with 4 file groups. No data will go there, no tables are there, nothing's there. I learned my lesson, so I'm going to go this way now. The next thing I'm going to do is I'm going to add some secondary files to, why does this not like me today? I'm going to add some secondary files to my database. So I'm going to add one NDF file. So you can only have one MDF file in a database. If you want to add secondaries, you have to add NDF files. So I'm going to add 4, 1 to each file group. And you'll notice, as hopefully I wait for Management Studio to come back to life, right here I'm specifying the file group that they're going to. So 1 on file group 1, file group 2, file group 3, file group 4. And it's frozen again. I have no idea why.
Maybe it is prompts trying to connect to the server or something.
It's all local now. Hey, it's back.
Great. So is an NDF equivalent to MDF just on a file group specific?
It's just, yeah, it's just a secondary
The
file.
way it works is that there's one MDF per database, and so if you need additional files, they become NDFs. Just like another.
But are they storing everything on the MDF or just?
It stores them on where you tell it to. And I'll show you, you'll see examples of that as we go through this. So I'm going to go out and show you my file storage now, because I want you to see what SQL Server has done now. So I go out to my C drive, to my SQL folder. I have a data folder, and you'll see here's my MDF. And I have 4 folders underneath that. And, okay, hold on. Copy and paste there. I promise it will do what you tell, exactly what you tell it to do.
You're writing code.
I know I'm writing code in a demo. Sorry. Not only that, but I'm going to take 30 seconds and start over again. So it looks right. So let's go back to here for a second and talk about some of the, let's go a little bit more. So as you design your table and you're thinking about whether you want to partition a table or not, one of the things you have to remember is, how is my data structured in this table? What is it used for? How do I need it to function as queries come in and out and data is requested? And that's, a lot of that is going to direct you in a way of how I want to partition my table. You want to partition the table in the manner it's used. So what do I mean by that? So you may have a column that is ID and it's an identity field and it's 1 to 1 billion because it's got 1 billion rows. And the question you have to ask and that's what you've got your clustered index on. Just because you want a clustered index on a increasing number, right? Well, how many queries come in and query your table based on that ID and that identity field? If the answer to that is 0, probably not a great column to use for table partitioning, because you're only going to get efficiencies based off of the used data. So if there's another column that makes more sense, then I would use that other column. Okay. So let's go reset.
Yeah, you're.
Thank you. All right, I think I'm okay. Let's go back and make sure. Okay, so now we've got 1 NDF per folder. Now, why does this matter? It really doesn't. But I want you to go back to that idea that we had, I talked about at the beginning, is let's say you have data that is, you have to keep 100 years of data, but really only the last 100 days is ever queried. But you have some policy in place that says on your data warehouse or in your production server, you keep all data. You never remove any rows, but you want to make once that table gets big, it starts to get slower, right? And so let's say we want to get to the point where I want my data to be fast, and I want it over here. But all this old data that I'm just keeping her out for historical sake, I want to put that somewhere else. So let's pretend, and I've only got a laptop with 1 hard drive, but let's pretend we're on a server with 8 LUNs on it. And I want to stripe that table across 8 LUNs, and one of them on the SAN is tier 1 storage, and one of them is tier 3 storage, and it's a little slow. So all that old data that doesn't get queried anymore, I'm okay putting it on slow disk because it doesn't get used that often. And if it does, I'm okay if that query runs for 5 minutes. But this stuff that gets used all the time that constantly is used, I want that on my fast. I want to make sure that's available and fast. So I'm trying to simulate that by giving a file group with kind of different paths. Okay. So the first example I want to do is I want to create just a basic numbers table. And we'll wait for Management Studio to get along with me again. Okay, so this fancy query, all it does is count from 1 to 100. So to do that, I'm just taking the output of this fancy CTE and I'm putting it into a table called numbers. And then I'm going to select star from numbers. So you can see if I hit F5. Okay. So if I hit F5, you'll see that all I do is have a table that is 1 to 100. So this is going to be my simple example table. This isn't partitioned. It's all on primary because that's what SQL Server does by default. And I haven't changed any settings to say that it is partitioned. In fact, I'll show you that I haven't done anything fancy. Get back to my other location. So I've got a kind of more fancy query here that just selects from a whole bunch of system parameters. I pulled this off the internet. There's lots of blog posts about queries like this to be able to see how your data is structured across your environment. So this is essentially just a query that says, tell me what my partition environment looks like. And if I run this right now, the answer is going to be empty because I haven't partitioned anything yet. So now we're going to kind of get into the nuts and bolts of what it takes to partition a table. Okay, it requires 2 things, a partition function and a partition scheme. And these by themselves do nothing. They just, misspell numbers. Okay, it doesn't matter. So here's my 100 table, and the partition function says, where are my boundaries? So my boundaries are where does one table start and the next, and where does one horizontal partition of data start and where does it end? So in this example, I'm saying I want 3 boundaries. There's actually 4. So there is negative infinity to 10, and then 10 to 35, 35 to 75, and then 75 to positive infinity. That's essentially what this part is saying right here. Now, the other part of this is that you have to take into consideration is range right versus range left. And I'm going to show you an example of that using a slide that I stole from an awesome presentation from Catherine Wilkinson. And here's how range right versus range left works. So it's essentially where the boundary data lands in the table. So if I go range left, then 20 is going to end up in the previous boundary or table horizontal partition. And if I do range right, then it ends up in the next partition. So why does this matter? Well, maybe in a table from 1 to 10 or 1 to 100, it's not a huge deal. But dates, it becomes a really big deal because if I take that 100-day example again, and I say, I want 100 days of data. I've looked at my data. I know that the 100 days is always the data that's used 98% of the time. And if I put that 100th day in the wrong place, then I may end up causing that query that's always ran, or the queries that always run, to query 2 partitions instead of 1. So what answer is right? Depends, which is the favorite answer in SQL Server.
So, and it's always less than equal is what it's getting at too. The number that you give there is less than or equal to that, to the number. So the 20 is over in the left, the 30 is in the left, 40 is in the left.
Yeah, so in range left, it's going to be essentially,
greater than or equal to.
Yes, greater than or equal to. In the other one, it's just greater than.
I just think of that because that comes up too when people say, okay, if I have a range, I said, you know, less than 20, I wouldn't actually get the 20.
Yes.
But this is less than or equal to.
Yes. So
The one that gets me is dates, because one of them,
Well, it'd be the same thing there. I'd want to know, is it less than equal or less than?
but it's like at midnight, one of them will go this way and the other one will go this way.
yeah, so
Right?
SQL Server is very little on date. So if I say today, if I put a query together that says where equals today, and I just give it a date, it's just assuming midnight. This date at midnight exactly. And so if here's the other part you have to remember when you're doing range right, range left, is if I do left, then if I do range left, then where is my data getting cut off at? Because at 12:01 a.m., it's going to flip over to the other partition because that boundary is at midnight. So all things that you have to take in consideration when you're planning your architecture for table partitions.
So it might be a little easier to see if you're just using the data type, because then you just have date, you don't have time.
True.
But it would probably be more confusing because then you can't see the time.
Right.
To know whether it was this day or this day.
Yeah. So we'll get into some examples of this and it'll make a lot more sense here in a minute. But it's this one concept is super important as you start to do your architecture. Okay, let's go back to SQL Server. All right. So the next part that comes into play is the scheme. So the scheme is the mapping of the data. So what it's saying is this 10 is going to go on file group 1. This 35 boundary is going to go on file group 2. The 75 boundary is going to go on file group 3. And everything above that is going to go on primary. All right, so let's create these two. And again, I haven't done anything. I still run this and nothing's partitioned. I haven't done any magic yet. I've just created the framework. That's all that's happened so far. Okay, so how do I partition a table? Well,
Quick, the framework was all per database, right?
Per database.
There's nothing we're turning on at a server level. Okay.
Correct. And it's all really, I mean, reuse of a partition is all up to you as well. And that I'll show you that here right now because I'm going to create. So I created this numbers table right from scratch. Nothing exists for it yet. I just created it from a select into. Doesn't have any indexes. So I'm going to give it a clustered index on the n column, which is the only column in the table, and I'm going to partition on it. And you do that with this. Now, normally when you see a partition or when you see an index created, it would say like on primary or on file group 1 or whatever the name of your file group was. Well, when you're partitioning a table, you're partitioning on the scheme because you're telling SQL Server, I want you to figure out where to put the data based on the function and the scheme that I told you. And so you'll see here I'm doing my partition scheme numbers, which is what I created right here. And I'm telling it what column I want to partition on. So I'm n, only thing in there. And when I run this, is it saying that this table doesn't exist? Oh, I know why.
It gets me every time.
All right, we're gonna go and fix this. It was so good about putting, okay. Now let's switch this back. Okay, so now I have a partition table, and let's look at the data because there's a lot to be seen here. So if I look here, you'll notice that I've got nine rows here. Oh, let's do this one more time. I've got 9 rows on my file group 1 because I put that boundary on 10 and I said range right, which meant that the 10 is going to fall to the next partition. So I've got 9 rows here. I go up a level to file group 2 and you see now there I've got 25 because I've got from 10 to 34 sitting on that file group. And I go up to the next level, I've got 40, and that 40 goes from 40 to 74. And then I go up to the next level, which has 26 because it's 75 to 100. Now, if I were to add row 101 to this table, it would land on primary. And not because by default all data goes to primary. It would go to primary because I've told it everything above 75 goes to the primary file group. It's on partition 4. Everyone with me? Okay. All right, so what does this get me? How does it help? That's the next part I want to show. So I'm going to run some very simple select statements and show you the execution plans. So the first one is I'm just going to go where the number equals 9. Bump this up a little bit. The first one just where n equals 9. And of course we're going to get 9 back. But what we want to look at is the execution plan. And you'll notice that right here, it queried, my table is partitioned, and it only queried one partition. SQL Server knew that 9 is on partition 1. I know right where to go get it. So on a 100-row table, partition's not buying me a ton, but on a billion-row table, if SQL Server knew exactly what partition to go to get its data, you can see how that query is going to be much faster. You'll also notice here in the seek predicates that it's only doing one seek. It goes right to the data, knows exactly where it is. Okay, next one. So the next one I'm going to do is between 11 and 40. So if we think about our table partition right now, we know that 11 to 35, or 10 to 34 is on partition 2, and then 35 to 75 is on the next. So we would expect it to query 2 partitions. So here we are with our 2 partition count. But when we look down here in the seek predicates, a couple things you'll notice. One is the first thing it does when it finds these things is it says, where are my dividing lines at? Because the first time it queried it and only got 9, it said, oh, clustered index, I know how to do this. No big deal. But now it's saying, okay, you're giving me 2 numbers and a range. I have to know where my boundary lines are. So the first thing it does down here is it goes down and it says, I need to find out where my lower number is. So you'll see that it's looking right here for the lower number. And then it needs to go here and get the higher number. So that's the next seek. And then down here, you'll see it just does one query right here and goes and gets the rest of the data underneath that one there. So right here is where it goes and it knows where the data is now, and it goes right to the partitions and gets the data. All right, next one. So now I'm going to say where the number is less than 76. So think about our partition boundaries now, and we know that 76 is all 4 because of how the boundaries are. So the top level is at 75, which means that 76 is going to be right above, or the boundary is at 75, and 75 range right is going to put 75 in that last partition. So it's going to scan the whole thing this time to get all this data. But there's a couple of things that I want to point out here, because while this looks like it's an easy thing, it actually, so here's my exactly how I figured it queried all 4. But notice my seek, it only did 2 seeks, because it went and it said, wait a second, where's 75 at, or 76? Oh, that's the whole thing? Okay, I just need to do 1 query. I'll use the clustered index. So I still got better performance this time, because even though I had to hit all 4, instead of it having to go find out where all the boundaries were and then do a bunch of analysis, it just said, oh, this is the whole thing, use the clustered index. Any questions so far? All right, finally, let's do a number, but I know this number is not in my table, right? But the exercise is still valid, because where do you think SQL Server is going to go? So it only hit 1 partition. Any guesses on which one?
The no primary.
It went to primary. It went to 4 because we said at 75, everything above 75 goes to primary. So it said, oh, this number is above 75. So I'm just going to go to the last partition and see if this number's in there, because that's where it would be if it existed.
So if you turn partitioning on, you're essentially having it call out to find its ranges no matter what, every single query essentially. Because it's got to know which range to hit, which place to go.
You need to put a date.
Yeah. So good. This is a good segue.
Is here in the seek predicates, you're always going to keep seeing range partition new, because it's looking up the metadata about the key to tell you where to go. So every one of those is going to have that step to look at. Okay. Yep.
Every one of them. So, but where you get, so while you have that, that's going to take time. That lookup takes time, but it's minuscule compared to when you're scanning a billion row table, right? And so this is where this was a really simple look at how the partition table works. But think about if every one of my queries on a billion row table with 1 column, again, I'm kind of killing my idea here a little bit, but we'll get a little bit more advanced here in a second. But if every query that comes in queries that end to find a range or a number or something like that, if I can take it so it only has to look at 250,000 rows instead of a billion to find, even in a clustered index seek, if it only had to do a clustered index seek on 250,000 rows versus a billion rows, your query will be faster. Now that's the architecture side you have to be careful, is you have to make sure that you are partitioning your table on the data that is used in your queries. Because if I had 5 columns in this table and none of them used n and they all used another value, this doesn't mean anything, because it's not ever going to get used by your queries. The only queries that will get the performance enhancement is the ones that use your partition value, your partition key.
Can you repartition these tables?
Yeah, so great segue. So that's exactly what I'm going to show now. So I showed you a table of 1 value, really small, didn't exist. I'm starting from scratch. Well, it's not until that table turned into a slow behemoth that I really cared about partitioning. And if I would have known 5 years ago when I created that thing that it would become a billion row monster in 5 years, I probably would have partitioned it to begin with, but my hindsight's always better than my foresight. So now I want to take this humongous table and I want to partition it. Well, it's harder to do it that way. So when you are, it's the same operations you would think about if you were going to change a clustered index, or you're going to drop an index and recreate it. If you do that on, let's take that billion row table. If I were to re-index a table with 1 billion rows, how long would that take? Well, you got time. And then how much log space would that take? Well, now I got a space constraint. And so there's a whole bunch of things that play into that decision, right? So yes, you can, but what is the best way to do it? So when we did our environment, I didn't repartition any existing tables. I created new tables and I slowly dumped data into it. And we did like 5,000 loops to move it all through to get it from here to here. And for a little while I had double data because I had 2 tables with the same thing, but it made it so my environment was up the whole time. I wasn't blocked, because as soon as you kick off partitioning or indexing a table, it blocks all queries coming in until that operation's complete. So you have to, those are more things. Do I have the space on my log device in order to run a query that's going to run for 2 hours? And am I okay blocking all queries coming in for the 2 hours it's going to take to partition this table? All things you have to take into consideration when you're doing it. So, but the next example I want to get into actually uses data that was built into AdventureWorks. So I want to show 2 more, a little bit more advanced topics, which is sliding windows and then split merges and purges. Purge is actually called switch, and all really cool things. And so we'll get into some more advanced topics now. Okay, so to begin with, there is a table in AdventureWorks called sales row header, and SQL skills script makes a new table with a whole bunch more rows in it called, and adds enlarge to the name. So I just want to show you this data a little bit. So I have dates from, and I'm using the order date column. So I'm going to partition this table by order date, and I'll show you the data here in a second. And I have data anywhere from May 31st, 2011, all the way up to March 21st, 2017. And there is 1.2 million rows in this table. So it's a pretty big table, not massively big, but it's big enough. So let's just look at some of the data in here so you can see what we're playing with. This isn't a small table either. There's a lot of columns in here. It's wide. There's all sorts of, from strings to dates to integers. There's all sorts of different data types in this table. It's more looks like a production table, right? And this is what we would be, in a real world example, this is what we'd be partitioning. So the first thing I want to do is, because I'm using 2014 and not 2012, is I want to, or not some older version of when AdventureWorks was created. This database table has the older data types. And let me just show you that real quick. And because I'm using it, I want to show you that I can do this on the new stuff and the old stuff. So we already did an example of not changing anything. This time I want to make sure I'm using current data types. So right now you'll notice that order date's a date time. I'm going to change it to a date time 2 because that's the new data type that SQL Server is using now, is date time 2. So the first thing I'm going to do here is I'm going to alter my table, and I'm going to change order date to a date time 2 7. One of the things that's nice about the new data types in SQL Server is you can actually get precision in your dates. So this one, 7, I think cuts it off at the millisecond. You don't get all the way down into the nanoseconds that you can. So I'm going to just change this table and change the order date over to a date time 2. Okay. Now, the next thing I'm going to do is I'm giving it my values again. So here's I'm doing a range right again. And here are my dates. So I'm doing my first partition up to January 1st, 2012. And then my next one boundaried at January 1st, 2014. And then finally my January 1st, 2016. So those will be my boundaries of my partition. And same structure as we did last time. The first one goes on file group 1, next one on file group 2, the next one on file group 3, and finally all the data past that will go on 4, or on primary, excuse me. So let me make these two partition functions and scheme. And we will change so from here on, this is the same query. The only difference is I'm just looking for a different table down here. If I ran it without this, you would see our numbers example in there. So just to make it so we're looking at what we're playing with, I added that where clause in. And you'll notice that I don't have anything set up for that table yet. Nothing's partitioned because I haven't done that work yet. So this one gets a little bit more advanced. So if I want to partition my table here, the first thing I have to do is that it has a whole bunch of existing indexes. And all of them have to go away because none of them are indexed correctly. Okay, and then the next thing I have to do is I have to recreate all those indexes again. So there's two things you have to remember when you're creating a partition table on something that's existing. One is that column has to be in every index. So I'm using order date. That order date column has to be in my index structure. I can't have it here, or sorry, I can't have it here and not up here. They have to be, it has to be something you're indexing on, and it has to be in your scheme. Okay. So, and I have to do that on every index, not just my clustered. So this one, I'm using AdventureWorks, and AdventureWorks created by Microsoft, and Microsoft wants to give you a database that has all the different bells and whistles in it, because this is where you're learning stuff and playing. So they've made clustered indexes, and it's on primary keys, and they've created unique non-clustered indexes, and they've created just normal non-clustered index. They're giving you a wide variety of stuff. So I'm dropping all of that, and I'm recreating it exactly like it was. I'm just partitioning it this time. So if I were to go out to AdventureWorks and scrub this table from just normal standard AdventureWorks, it'd look exactly like this without the partition column and the partition function. So I'm not doing anything different except for that. So this has a few rows in it, and it'll take a few seconds to redo this whole thing. And when we're done, so one thing that's kind of fun is I can run this now, and when it gives me data back in between, that's what one of the times no lock is helpful. So you'll see I'm still executing over here, but I'm getting data back. So you can actually, if you run this fast enough, you can kind of see numbers moving a little bit as it moves data between partitions and does its thing. And if you're hitting it at the right, this one doesn't run long enough to be able to see it, but if you with all these no locks and you're okay reading dirty data, this may be one of the good examples of okay to use a no lock.
I was gonna say, don't let Randy hear you. There's a few people that will disagree with you, just like
Anyway, so this is done. And so if we go run this one more time, so I found this kind of interesting because you can see for the AdventureWorks company kind of how it grew into a bigger company. So that first year they didn't do a whole lot of orders, and then they got a little bigger, and then they got a whole lot bigger, and now I'm not even through the whole year yet, and I'm already about half of what I was. So you can it's a little bit of interesting insight, a little bit of if you partition it on useful data, how you can kind of see some trends and analysis just on partitioning. But you can kind of see how all of this laid out into my into the different file groups. Okay, so the downside of doing dates is the upside of doing dates. The downside of doing dates is date keeps changing. So eventually I have to maintain this thing, right? I don't want my end cap to be everything in the future forever. At some point I want to say, you know what, I need to make a new partition, or I may say, you know, this old data down here, this 7,800 rows, I don't need that anymore. So I need to do something with that. Or I may decide, I did 2016, I did that wrong. It should have made a 2015 and a 2016. I have to maintain this table. So let me show you how that works. That's where the splits and merges come in. So splitting a partition is essentially you're giving it one of the dates or the file. Okay, let me take it back. Okay, so right now I'm saying 1/1/2012, and I want to split everything older than 6/1/2011 into its own partition. I really wanted that data separate. So the first thing I have to do is I have to alter my scheme that I created, and I have to say, so the scheme was where the data lands, okay? Then I have to say, I'm going to have you make a new partition, and the next time you do it, I want you to put that data on file group 1. So you have to tell it where to go next, and then you say, and I want to split you on some other date. And so when I go back and look at that, you'll notice that now I have 2 partitions on file group 1. And how long did that take? I moved 43 rows like that.
And how does it do for 5 billion?
It's pretty fast too. The cool thing about table partitioning is it's all metadata changes. The SQL Server has all the data where it needs it, and you're just changing pointers. If you're moving between file groups,
I was gonna say,
then that's where it gets a little.
Yeah, we ran into a sticky one where we actually wanted to put the next file group onto another drive. And then when you said split, whatever you had to move over literally had to copy
You are correct.
and zeros from one drive
You
to
are
another.
absolutely correct. So we dealt with the same thing.
So be careful.
Yes. So we dealt with the same thing, and our answer to that was, well, let's not move 5 years right now. Let's move 5 minutes at a time and loop through it until I've moved 5 years. And then the nice thing that does, so as soon as you start an index operation, which essentially this is almost an index operation, you're moving data around, your table's locked. Can't add anything, can't query from it. It's all locked up while the operation completes. So for us, when we said, let's move a minute of data, we run this every day. So I'm moving 1 day of data every day to the next file group, and it follows its way down the waterfall from new data to old data, and I get rid of it. So when I move that 1 day from here to here, I've got 100,000 rows or 250,000 rows or whatever it is, million rows. And I don't want to necessarily lock my table while this whole thing runs. Moving 1 million rows takes a long time. So for us, instead of moving a whole day, I move 1 minute, and I loop through that enough times, and it's actually pretty quick. And what it does for us is it makes it so someone can write a query, it can sit there and get blocked for 30 seconds while I move that 1 minute, and then their query runs, and my next partition thing gets blocked by the query while it runs, and then it gets up and then it blocks everything else for why it moves 1 minute of data, and it just loops through that. It's an overnight operation, and I know it's going to take a little bit of time, but the nice thing for me is it doesn't block my entire environment for an hour while it moves data. I've got one of our major databases is over 1 terabyte of data, and most of the tables are partitioned. In fact, one table in that database is 80% of the database. So 1 terabyte, 80% of it. It's a big table. And I have that partitioned because it's already 1 terabyte. I don't want to get any bigger than that. So I keep it partitioned so I can get that old data that I don't need to keep out of there. The data retention policy really helps me because I don't have to keep data forever. But I have to have an efficient way to be able to remove data when the time comes. So we'll get to that here in a second. So I've moved those 43 rows. So I picked 6-1 on purpose because if you remember when I showed you the example, the last day of data that I had was 5/31. So these 43 rows are the one day of rows that happened on 5/31. Okay. Now, if I want to put those back, it's really easy. In this case, I'm going to do a merge, and I'm going to merge on one of the boundaries. So for this one, you have to know what the boundary is. So I'm going to merge that boundary, and the data always stays. So whatever boundary you put in is what's staying, and everything else moves into it. This is an important thing to know because right now I'm only moving 7,700 rows back down into, so it's going to look like this. It's going to look like this row with 7,700 rows again, but SQL Server is actually moving all 7,700 rows of this down here, and then it's going to have that boundary. That's the operation that it does. So be careful of that, because if you need to merge and you're moving 500,000 rows into a partition of 100 rows, it's going to take some time.
But in your case, it's the same file group, so
it'll be really fast. Yes, this one will be really fast. All right, so let's run this one. And we'll go back over here and run it again, and look, now I've only got 4 instead of 5. Now that's all cool. I want to split this back out because the next operation I want to do is a purge.
So do you usually just see a SQL agent job maintaining this where you're either using SQL or
something like that. You have an agent job that you schedule to run at 6 o'clock or 8 o'clock or midnight or whatever. It's all custom code, right? You have to go through and figure out how I'm going to split this up and how I'm going to maintain it and how it all works, and all of that's custom code. There's no go on the internet and download a script. But once you figure that out, for us it's really easy because I do splits and merges every day, and it says I'm at this minute and I'm going to go to the next minute and I'm going to move all the data, and then it loops through again. Okay, I'm going to the next minute, loops up. So I'm running the same script every day, and it loops through it like 80 times or whatever it is to, get through it all. But it's really easy for us because once we have it set up, it just takes care of itself.
A question, just a little bit tangent, still on topic, but when you talk about the retention policy, is there any tool that sits atop SQL Server that allows you to say, okay, for this type of data, here's the,
I don't want to say there's no tool. There's nothing built into SQL Server to do that. I'm sure there's some vendor that's maybe made something that does stuff like that.
But that's custom as well. Knowing your data and knowing what the retention policy is. And then knowing where those custom scripts are going to be in case that retention. So all of that's manual.
Yes, it's all manual.
And if somebody changes that, you got to know
where to go and make the change. And Okay, so the next thing I want to show is purging data. So for me, getting rid of that old data is super important for me because it keeps my database size down. And so one of the big selling points of table partitioning for me was it's so easy to get rid of data, and it runs like that. It's really cool. But you got to have some structure set up to do it. So the first thing you have to do is you have to have a table on the same file group of the data that you're getting rid of that looks identical to the table that you are switching in and out of. The schema has to be exactly the same. The only difference is that instead of so here you would say, previously we would have right here, we would have like on PS order date, right? Because it was partitioned. Well, now I'm saying I want to move, what I want to do is I want to move, let's rerun this. I want to get rid of these 43 rows. I don't need them anymore. Okay, so I need to make an identical table on file group 1 because that's where this data lives. So everything has to be identical, from the indexes, to table, everything. Now to make that easy for me, the way my brain works, it's easier for me to make another schema and have that table named exactly the same and have all the objects named exactly the same. If I put it on the DBO schema, then the table has to be named different, and the objects and the indexes have to be named a little different. The naming of the objects isn't what's important, it's that the structure is the same. But my brain reviewing this is so much more, it's so much easier for my brain to analyze this when so I make a purge schema, and I make all my purge tables go on the purge schema. So I'm just going to run this. It's going to make a table. And now I've got a table that's identical in the purge schema. And then switching in and out is actually really easy. This is all you need. So all you're doing is you're altering the table. Let me expand this a little bit, make it a little bigger. So all you're doing is altering the table that you want to move data out of and tell it where to go. So I want to alter my sales order header enlarge table. I want to switch partition 1 to purge, to my purge table. So how do I get all of this? If I go back and look at this, it tells me right there this is partition 1. So I want to move 5, and I have to have an identical table on primary. If I want to move 2 or 3, it tells you where the data is that you need to move right here in this query. So I want to move partition 1. So it tells me these 43 rows. I want to move partition 1 to my purge table. So we all just saw me create it. There's no data in here right now. I'll run this, and now I have 43 rows. And when I go run this guy again, this guy still exists, but it has 0 rows. So I know I only moved 43 rows, and then our brains go, yeah, 43 rows, that's not a lot of data. Of course it's going to move fast. This could have ran 500 trillion rows, and it would have moved that fast. Because all you're doing is a metadata operation. As long as you're on the same file group, which you're going to have to be in this circumstance because you can't switch out unless they're on the same file group. So this is really fast. And then I know that I want to get rid of this data. So what's the easy way? Truncate table, purge. Because I want this table to exist still. I don't want it to go away. So I don't want to like drop the table because then I have to create it again. I don't want to do this. So I just truncate it, move on to the next thing. Really fast, really easy. Okay. So that's how easy it is to get rid of data. Now, the reverse of that. Let's say I have an ETL process that inserts rows into my billion row table, and it is super slow. It takes forever to insert a day of data into my super humongous billion row table. So partitioning helps me there too. So I can have a load table, and I put that day of data in my load table, and then I switch into my partition. Okay, so there's a couple of prerequisites. One is that, so I know this is my purge table. Let's pretend it's my load table. I have to have a check constraint on that table that enforces the rule of my boundary. SQL Server won't let you move data in unless it won't do the analysis for you and say, sorry, I couldn't move these 5 rows in because they didn't meet the criteria. That logic has to be pre-checked. So you have to have a check constraint on your load table that enforces your boundary rule. So because I want to move this data into that, back into that file group, I have to enforce that no data can be newer than 6/1/2011. So that's what this check constraint is going to do. Okay, and then I do exactly the opposite of what I just did. This time I'm altering my purge table, and I'm switching it to sales partition 1. So just the reverse of what we just did. Move it like that. Again, it doesn't matter if it's 500 trillion rows or 1 row, it's going to be just as quick. And now when I look at my purge table, it's going to be empty. And when I go back to my partition table, those 43 rows are back in there. Now, The one thing the partition you're switching into or out of, the destination table or partition has to be empty. It's not going to move these 43 rows for these 52. Doesn't work like that. They have to go from empty to table or from table to empty. So it has, the destination has to be empty. And then it's really fast and really easy. Okay. Any questions?
So how do you manage that? Like you have an ETL cycle, but you want to have it as current to date and your partitions are a week or a month long, but your ETL runs every 24 hours.
So what I would do something like, I would make a 1-day ETL table, and my ETL process would load into that table. And when it's done, it would make it would split your partition table to add another date. So you would get that empty partition at the top, and then you would just switch that in. And now your data from today is in your table. And then you're left with an empty one over here. So the next day it runs, it does the same process
So
again.
you just create a staging table.
It's like a staging
for
table.
1 day.
Yes.
Populate that, copy that into a different table name that you want it to reside in.
Yep.
Or move, and then truncate your staging.
Yeah, well, the switch is going to
The
switch is going to take your empty partition, which is going to make your load table empty again, and now your data is in the partition table. So your load is faster because it's loading into something empty. It doesn't have the index operation, all that stuff is lighter because it's empty. And then as long as your tables are exactly the same, that switch in is super quick.
Your ETL checks on it against all of your data you need beforehand.
Yeah, you would all your checks, goes against your daily load.
So load and then ETL check and then switch, those three.
Yep. Anyway.
Yeah, it's not uncommon to see a staging table inside of a data warehouse too. It's just, then you would have to just, like you were saying, where you have to do your checks. I would see that all being done before I ever dumped into my staging. Staging usually for me was nothing more than I'm inserting the data into a bigger fact table.
Okay, so you would have a pre-staging.
Yeah, I typically, when I do an ETL or something else, I do a ton of work all before that, dump it down into a table in whatever form it wants, and then just insert it into the fact table.
I'd love to explore that, like outside of this.
Like I said, I haven't tried it with the switch method through partitioning, but any of the ones I've set up in the past have always been, there's a loading table that I dump it down to, and then that's inserted into the fact table. I used to use Merge, but we all hate Merge now. So.
It was fun while it lasted, right?
Yeah, for one event.
It depends on how much the previous DBAs loved it and you put it everywhere.
Yeah.
I did a whole ETL with it, and I regret it now.
Sorry.
I'm just glad to say.
Anyway, there's my references, stuff I pulled. There's a ton of great content out there from a lot of smart people on table partitioning, and to answer all your questions. And thank you.
Thank you. And you overcame the glitches.
Yeah.
Google Hangout.
Yeah, I'm blaming it on Google Hangout.
Google Hangout, the glitch.
Sounds like a movie.
Go to that one, yeah, and then hit stop.